Hello, my name is Kayla Levy, and this is my research that I've conducted over the summer, a Julia package for plausible inference software. I'd like to thank my mentor, Dr. David Ekman, as well as my sponsors, the NSF, and as well as the online REU program at Texas A&M University. So, to start, our objective of our research was to develop an open source software package for implementing plausible inference methods. The main things that we wanted our software to be able to be is to be open sourced, as well as written in Julia, which is a programming language, and also being user friendly for other users to use our plausible inference methods. So, our main goal with these plausible inference methods is to successfully screen out unsimulated systems based on predicted performance, which is called screening, or construct confidence intervals as a form of uncertainty quantification. So essentially, we can have two different kinds of plausible inference methods. The main motivation of our project was to enhance the accessibility of plausible inference methods for a broader range of researchers and users. Like mentioned before, having that ease of use, so bridging the gap between the software and the users, as well as the speed, so how we may implement parallelism when simulating these things. Accuracy, our plausible inference methods were largely based off of a previous written code in MATLAB. So seeing how the solvers compare to the MATLAB code and how accurate they are, as well as exploring the packages within Julia. And another main motivation is to expand the documentation of Julia. I don't know if any of you guys have heard Julia as a programming language. It's definitely not as big as Python or C++, but it's a very capable programming language. And so we're trying to add to that community by giving another use case of how Julia can be used and showing how the optimization solvers can be used within these simulated methods. And also being that it's open source, we can add to that documentation and expand the community. So this is a high level design method of what our software will do. We decided to use YAML files for the ins and the outputs of our software. So essentially a user will give us they'll input their simulation data as well as tweak some of the solvers and parameters they want to put within the software. The software does the math, runs the numbers, and will output all either the screening or the confidence interval results from the software. And right in between where that plausible inference software is, we will be using Julia and we'll be using Jump for the optimization solvers.
So this is the design method of our source code. This is the heart of how we will run our software. Starting on the left here in this orange box is a YAML file that contains user input and as well as their simulation data. The user input is based on the user's requested inferences, starting off with the type of inference that they want to do, whether that be screening or intervals. Next, after they choose which option, they can choose whether they want to run normal or gradients, or a relaxed or unrelaxed version of the software. Once a user has chosen how they want the software to be run, next they can start setting up the components of their optimization problem, whether that be convex or Lipschitz. And from then on, for screening only, they can select definition of acceptability, which has three options: feasible, near optimal, or close to target. As you can see, there's another part here where those are the optional parameters that a user can add through a YAML file with their simulation data and will act as a threshold that the parameters must meet. Next would be a 1 minus alpha, which would be the desired confidence level for the inference statements. It is represented by a slider bar that will display what confidence level the user has chosen, as well as a discrepancy string, which could take in possible values of 1, 2, infinity, and CRN. The simulation is based on the user's experiment. As the user has selected what their requested inferences are, we then move into either a screening or intervals, which require two different types of setups and have access to different types of functions within the software. Both screening and intervals will need to calculate a D cutoff value, which is where we will calculate here in the calc cutoff function. Once a D cutoff value has been calculated, will act as a threshold that will be later used in the code after we run the optimization solvers. As mentioned before, the definition of acceptability can only be used for screening, but both the intervals and screening can use the setup functions. And once a user has selected those, we will generate the A, C, and B components of the optimization problem. And we could then run into our calc min STD for screening or calc lower and upper bounds for intervals. And within these calculate functions, this is where we actually go to solve the optimization problem. And this is where we use jump and other packages to give us our DXO values that we then compare with our original calculated D cutoff values. For screening, if these D cutoffs that were simulated meet the threshold, then we can say that it has met the threshold and will be represented by a 1, and if not, will be represented by a 0. And for the intervals, we will produce a confidence interval of where it would meet based on their uncertainty.
So future works of our research would be to complete a GUI for users to add their plausible inference solver. Essentially, for now, our user interface is run mostly through the terminal, but adding a GUI would help sort of make that jump between having users input their data and directly be able to manipulate things within the software. As well as looking for ways to optimize the code to its fullest potential. There are so many ways that the code can be written. So we're looking for little ways where we can maybe add some more parallelism or just seeing how certain things are being called within the code and then tweaking those bits to make the code more fast and we can optimize it to the optimal level. And thank you.